Good morning, good afternoon, and possibly for some of you already good evening. My name is Gerald Verbeek. I'm the chair of the DFI Sustainability Committee, and I want to welcome you to this webinar that is titled EFFC DFI Sustainability Guides. You actually are going to get more than just an introduction on the sustainability guides, but more about it a little bit later. During the webinar, all attendees will be muted, but it doesn't mean that you cannot participate in this webinar. If you have a question, please use the question box. And after the presentations, the three presentations that we have set up for you today, we will have an extended Q&A session. But before we get started, let's give a little bit of background. First of all, what is sustainability? And really, the easiest definition is that it's really a balance between the environmental aspects, the social aspects, and the economic aspects. And where those three intersect, that is where sustainability has its home. Which is important, by the way, because quite often people are saying, well, if it's sustainable, then it cannot be economic. Yeah, those are just completely separate. But what you see in this chart is that the sustainable solution still needs to look at the economic viability. When the United Nations developed the concept of sustainability, they split it up in 17 different sustainable development guides or goals, the SDGs. And all those aspects can be considered. And in the previous webinar organized by the DFI Sustainability Committee, we asked some executives of American companies, why is it that sustainability is important and what should people be focusing on? Because you have 17 different SDGs, that is quite a bit of stuff. And the common answer in that webinar was that, listen, unless there's a financial benefit, people are unlikely to take action. But when you start thinking about sustainability, where most of us, you will see, and a little bit later in this webinar as well, where most of the emissions are due to the materials that we use. If we burn less fuel, if you use fewer materials, you not only reduce the carbon footprint, but also your project costs will be cheaper. And that's again restating and reinforcing the concept that sustainability and economic viability go hand in hand on this whole thing. So that's why sustainability is something that really a company should be focusing on. But the question then is how? How do you do that? What kind of basic tools do you have to really start implementing, start focusing on sustainability? That can be guides, it can be calculators, it can be flowcharts, it can be all kinds of different things. And what we have in this webinar is that we're going to give you examples of all three. Originally, we were only going to talk about the guides, but now Kimberly Martin will give that presentation about the guides, but then we will go one step further and we'll also talk about the carbon calculator. And Chris Nelsen will give some information about that. And then we have a flow chart where we see how the different players in a project, be it the owner, be it the consultant, be it the geotechnical engineer, be it the contractor, how they can all work together to get a more sustainable solution. That is what Will Haasz will be talking in his presentation. So with that, I want to thank beforehand Kimberly and Chris and Will for participating in this webinar. And I hope that the three presentations that they will give to you, the attendees of this presentation, will be very useful. And with that, Kimberly, the floor is all yours.
Great. Thank you, Gerald. And thank you all for joining us today. So I think we have a lot of great resources for you. I'm excited to get this out here to our members so you all know what's available and how to use it. So a few slides back, Gerald showed the UN SDGs and described how many of our own companies and many of our clients use the SDGs as a framework for our approach to sustainability. So really, it's important to ground what we do with sustainability in those SDGs. But how do we take the SDGs, many of which are only defined by the UN for governments of low-income countries, and apply them to our industry and to our companies? If you're asking that question, you're not alone, which is why the EFFC started a task group to write sustainability guides addressing our challenges and concerns. And because our DFI members were also interested, last year we agreed with the EFFC to make this a joint task group. So you will now see these guides co-branded between the EFFC and DFI, and they will include recommendations outside of just Europe, which is going to be really helpful to DFI members in North America, as a lot of what is going on in Europe is highly regulated, and therefore the implications are different for companies over there versus over here. So on this slide, you can see the map showing the current plan for the order in which the guides will be worked on and which SDGs will be addressed. You can access the first two guides from the EFFC website, but we're just wrapping up the rebranding, so you will see an announcement soon, I'm guessing from Agglison, when we have the final version of the new guide. It's imminent. The water guide and climate adaptation and resilience guides are well on their way, and we're actively recruiting for the well-being guide, and we'll move on to the environmental pollution guide next year. So please think of participating in the development of these guides. You'll see how useful they could be, and reach out to me directly if you want to be involved. So today, with this being a resources webinar, I'm going to give you a rundown of the carbon reduction and circular economy guides. First things first, how can you use these guides? We are trying to use the same approach for every guide, so you can open one up and have a sense of what to expect. Also, they're meant to be practical. That's why we use this what, why, how measure approach. So for each guide, we're providing information on what impacts geotechnical companies can have on the SDGs addressed, why these particular goals matter and why our industry should do something, how you can do something, and what metrics and measurements you can use to make sure your efforts are fruitful. Also, you could just use it for acronyms and definitions, because I know that could be the most confusing part about sustainability. So no judgment if that's how you get started. All right, we'll dive in now. So we'll start with the carbon reduction guide. This guide was made to address SDG 13, climate action, and SDG 7, affordable and clean energy. We're addressing climate action through carbon reduction, as the name implies, but we're also addressing affordable and clean energy because by focusing on carbon reduction, we will use less energy. We will also use cleaner energy. Starting with the what, I want to talk about what climate change means for geotechnical companies. The best way to talk about this is with regards to risks and opportunities. So some risks we might think of are with an increase in wildfires and the associated air quality issues becoming more frequent because of climate change. Might our available workdays in the summer be shortened or reduced? And how would that impact the bottom line for many of our companies? Another may be, will we face restrictions on using diesel-powered equipment, which likely makes up most of the equipment fleet in North America? And that isn't just a question for the future. In California, renewable diesel is required on construction work sites since the beginning of this year. So what kind of rules might come next? And this is a risk because for many of the contractors or site investigation companies on this call, the equipment we buy today may still be in our fleet in 15 to 20 years from now. Then we look at opportunities, and we can look at this through the lens of our project portfolios. What new kinds of projects will become more common, and are we prepared to work on those? What types of projects may not get permitted? If you're familiar with the projects along the Gulf Coast, you know some of the start dates for the LNG export facilities have been delayed. And on the flip side, what types of projects may be up and coming in the future? It could be things like energy storage products. And I'm sure some of you are already working on those projects now. So like thinking of this lens, particularly if you're working on a company strategy, you can use this guide to help you think about what the next 5 to 10 years look like in the AEC industry. But we can also think about what does climate change mean to our companies? So not just external issues coming in, but what are we putting out there? And when we talk in this way, it's common to think of our carbon emissions as outlined by the Greenhouse Gas Protocol, which is by scope. So scope 1 emissions are emissions from the fuel we use. This is in company-owned or leased equipment or vehicles. The majority of these emissions occur at the point of use, which is why it is scope 1. Then we have scope 2, which are emissions from the energy we use. These emissions typically occur at the power generating facility, so not at the point of use, so that's why they're scope 2. Then we look further down our supply chain, further into the emissions that we don't seemingly have a lot of control over, and those are called scope 3. Scope 3 includes transportation of people and equipment and materials and waste, but most importantly, it includes the emissions from the materials we use. So you can see on this infographic, It's likely our largest scope in the construction industry or the engineering design industry. So when we think of using cement or concrete as an example, the manufacturing of the cement occurs long before and may be far away from our site. But when we design for it, order it, and put that cement to the ground, we have a stake in those upstream emissions. And that's why they're called scope 3. So many people ask me, aren't these emissions then double reported? And the answer is yes, they are. So you can see in this diagram how emission scopes are rolled up, with ultimately the owner being responsible for all the emissions that occurred for that project. But the point of sharing this is to say we are all responsible. If only the owner reported this, then A, we as designers and contractors wouldn't know where our emissions are coming from. And then B, when the owner asks us to do something about them, how would we do that? By looking at our emissions holistically, we can all work together to find ways to cut them, which is fairer and honestly, it's going to be more effective. Okay, now to the why. Climate change will affect our companies and also our companies affect climate change, but why will we really change? What are the drivers for us? My colleague Luke Deemer put this awesome infographic together to lay this out because the drivers are coming from many different places. For example, we're trying to get our hands on lower interest loans, or more likely, our clients are trying to get their hands on lower interest loans, then there may be financial pressure or incentive to perform the work in a more climate-friendly way. We often point out that if we achieve efficiencies, like using less energy, that will likely cost us less money too. So that's another driver that has more than one benefit. We talked about the risk aspects of climate change, with many of us affected by the physical risks, particularly because we work and build outside. So that can be a driver to change. We may see our employees demanding more transparency when it comes to impact and measurable changes in how we're doing better. So we want to attract and retrain and attain the best people in our industry. We certainly may see client demand, which could come from clients making promises to their investors and stakeholders, but also may come from legislation. And the legislation may, in some cases, like in the fuel side of things, directly impact us. And in other cases, it may trickle down from our clients. So there are a lot of drivers coming from a lot of directions. At North America specifically, and this is outlined in the new version of the guide, we see a changing landscape from rules and legislation. Again, we may work for listed companies or be a major contractor for federal projects, but you may want to be aware of the requirements that are pending for the owners and clients we work for, because they may have to do things like report all of their scope 3 emissions, which I showed you, if you're working for them, includes your emissions. So how do we do this? A great place to start is the carbon reduction hierarchy. This is a simple yet effective tool that shows us the steps we need to take to make a positive impact. To use this, we start with eliminate. This means eliminate new foundations if you can. That sounds bad, but there's still a lot of work involved if we want to do something like reuse existing foundations. Eliminate may often not work. I think we could say most of the time it won't, but asking, do we need to build and do we need foundations is a good place to start because it will have the biggest impact on reducing carbon. Once we know we need to have foundations, then we move on to reduce. This is efficiency improvement and optimizing design. So for example, if we have 100 drill shafts, can we do a load test and reduce the length of each of those shafts by 10 feet? I consider this step to be finding our most clever and best design with a carbon lens to reduce our emissions. Then if we know we have the most efficient design and the most efficient way to install it, then we can move to substitute. This is when we say, we know we need concrete for our drill shafts, but we want to use as much low carbon material like slag or fly ash as possible in our mix design. Or we know we need energy at our equipment shop and yard, but we're going to purchase green energy to meet our needs. And then finally, we're going to compensate. If we have the best design possible and then we can purchase high quality carbon offsets for the rest of the carbon. So we don't want to do business as usual and then just offset. That's greenwashing and could really backfire on your reputation. We want to put in the work and then offset as needed. And likely, if we want to get to zero carbon foundations, we will need to offset. So how do we apply this carbon hierarchy across our organization? Well, in the guide, we've actually broken down this part into many sections. So if you're a designer, you can flip to that section. If you work on site, flip there. If you want to know it all, read the entire guide. We'll go through some quick examples as we have some case studies that will now be included in the new version of the guide. But first, a reminder that if we want to do this, we need to measure, make a plan, report on how it went, make changes, and improvements for the next cycle. And adopting the cycle of thinking is important because a lot is changing when it comes to carbon reduction, whether it's fuel availability, material availability, or legislation. So part of our review may be incorporating new and innovative techniques or materials that become available. As I mentioned, the guide goes into details in each area, but let me go through a couple. So first, design. There are many ways designers can help to decarbonize, whether recommending and allowing for reuse of existing foundations, because designers can be the gatekeepers on reuse, or optioneering, meaning giving the client many options and providing carbon estimates for each. We could look at a project holistically and say, for example, hey, we could go with ground improvement here, but using drilled shafts with geothermal loops might provide lower carbon over the lifetime of the building. Designers are able to challenge constraints on projects, which could be schedule constraints or might be loading conditions that aren't realistic. They can look at design efficiency, writing less prescriptive material specifications, and designing the foundations we build now for reuse later. As an example, on a nuclear project, the designers looked at what was really needed for the outfall system, which allowed them to reduce the tunnel diameter and change tunneling methodology, saving over 500 tons of carbon emissions and 6 months of schedule. So it's not just carbon, time and money can be saved as well. Materials are always fun to consider. We can reduce quantities, which could be through design, but also through looking at waste on site, use lower carbon materials. We can reuse materials. We can engage with suppliers to see what low carbon materials they may have available. And we can consider expanding site characterization to help us understand material compatibility and optimization. An example of material reuse is the case in North America, where the contractor identified waste concrete from demolition on site and was able to use that in an aggregate pier that saved 60 tons of carbon by eliminating transportation of waste off-site and new aggregate transportation onto site, which resulted in a 30% reduction in carbon, and I have to imagine cost savings as well. Then we can look at energy. Where can we use grid energy instead of a generator? Where can we use less energy, either by optimizing the equipment or changing the technique? How can we educate our workforce to reduce idling? And when we have done that, can we substitute for greener energy from the grid, like in our offices, or also from the fuel we are using, like with renewable diesel? So here's a case where by connecting to the grid for a batch plant, the project saved $100,000 in fuel and 290 tons of carbon emissions. And the carbon savings will increase over time when we switch to the grid because the grid is becoming lower carbon over time. And in some places like Washington and Oregon, the grid is already providing near zero carbon. So finally, we get to measure. This guide breaks down what we should consider for each scope. So common scope 1 emissions are diesel and gas use, natural gas consumption in offices, typically for heating oil and grease for equipment, or for heating, and then oil and grease for equipment, and maybe biofuel like biodiesel or renewable diesel. For scope 2, we need to look at the energy we use in our offices and yards, then determine the emission factor for the grid we're attached to. This is actually all in the carbon calculator by grid, and Chris can touch on that later. And for scope 3, you need to know quantities of each type of material that you're using or you're designing for, transportation distances to get those materials to site, and also business travel. So luckily, as I mentioned, emission factors are already in the carbon calculator, so you can use those if you want to calculate your company's emissions or project emissions. But also if your company wants to participate in the EFFC program to report your emissions quarterly, you can follow the link here and we can put that link into the chat so you have it. But all you're going to do is enter in your consumption and you'll get a response with your emissions. And you can do that yourself in the carbon calculator as well. So now you know how the guides are set up, so I'll move a little faster through the circular economy. The circular economy guide addresses SDG 12, which is responsible consumption and production. And as I go through this, you'll see that the SDGs and guides are interrelated, which is good for us because by addressing what seems like one SDG, we can oftentimes positively impact other SDGs as well. So what is the circular economy? It's a change from the way our economy mostly functions now, which is the linear economy. So if we think of most goods in our economy, they're made, bought, used, and then sent to the landfill for the end of their life. But if we think like the circular economy, there's the linear economy. And if we think like the circular economy, then the end of life and the raw material extraction become connected. And this is where we reuse materials and products mostly as they are instead of sending them to the landfill. Then we only have to supplement as needed. And this may sound a little out there for the geotechnical engineering industry, but it is less out there than you're probably thinking. And that's what this guide is for, to help you understand it. So circular economy principles include eliminate waste and pollution, circulate products and materials at their highest value, which we'll talk more about in a bit, and regenerate nature. This does indeed impact more than SDG 12, but for this guide, 12 is the main focus, so more of eliminating and circulating rather than regenerating for now. So why does this matter? Again, we have many of the same drivers as for carbon reduction. I think in North America, this is less mature, but we do see regulations and rules like the Federal Buy Clean initiative, which encourages the use of recycled materials. And note that the Corporate Sustainability Reporting Directive, CSRD, in the EU is coming and does include components of the circular economy. So this may not directly apply to you, but it could apply to your clients. So it is something to be aware of. Also, we hope that by decreasing demand for materials, new materials, we can reduce costs and maybe in some cases reduce our risk regarding our supply chain. We have another hierarchy for the circular economy, again, related but not exactly the same as the one I showed for carbon reduction, starting with foundation reuse, then reuse materials and keeping things we own circulating at its highest value. For example, I like the concept of extending the useful life of our equipment. Then making sure we eliminate waste and pollution as best we can. This includes careful ordering of materials. We don't have a lot of waste. Also trying not to use hazardous materials. And finally, disposing carefully. So we try not to have big cutoff of steel piles as an example, but if you do have steel scraps, making sure they're recycled. And if you think about this, I think many of us already do this as much as possible because it does have cost savings associated with it, but maybe we could do more. And also now you have a name for it. Some quick wins for the circular economy are reusing spoils on site, reusing drilling fluids for as long as possible, reusing materials, again, something that may also reduce carbon, using trading or reuse schemes, which could be internally, like with moving excess pipe. One project may have bought to another project instead of ordering new, or externally, which I hear in Europe, there are marketplaces to help reuse material, especially near where it's already located. Reducing waste and also consumption is something designers can think about, and thinking about how you can influence design with the circular economy in mind. Again, this isn't new to our industry. Here's an example of how oftentimes for micropiles, we reuse tubular steel that comes from the oil and gas industry. So a quick concept I want to introduce is the concept of recycling and downcycling. So you've probably heard me say, and you see it referenced in this guide, circulate at the highest value. Recycling is keeping things at their highest value. So metals are a great example. Our recycled cans are recycled to be cans again. But downcycling refers to materials that lose quality or functionality when they are recycled. So plastic is a good example. It loses quality and also it's not infinitely recyclable. We can also think about this with concrete, right? If we put concrete in the ground, we say, oh, it can be recycled later. When we crush concrete at the end of its life to use as aggregate, that's a lower value product than the concrete was to start with. So that's downcycling. So just something to think about when we talk about recycling and keeping things in the economy at their highest value for as long as possible. Okay, back to the how. A major area for circular economy is reusing existing foundations. Gerald hosts an entire conference dedicated to this concept, and also that conference has a lot of good resources available for free at foundationreuse.com. Another free resource is the June-July issue of Geostrata that was focused on reuse. But also think about how what we build today can be used tomorrow for another building or another project. As an engineer or contractor, what would you want to see to convince you in 30 years that the foundation you installed today was still sufficient for use then? These are all concepts covered in the guide. So finally, I want to highlight the metrics you can use for the circular economy. Waste diversion is a great place to think about, but you may need to start by simply measuring how much waste you produce. You may want to use waste material in your foundation, but you need to engage with your suppliers to understand what is available. And extending the useful life of your equipment may be a better solution than buying new equipment, but also consider the fuel use and efficiency of new equipment versus old. There's lots of trade-offs. And again, if you do something, use the improvement cycle to measure and get better. So my final thoughts on this amazing resource is go download these guides. The new DFI co-version will be available soon, so be sure to get those when they're uploaded and you get the notice. Today, I just gave you an overview of what's in the guides, but there's so much more detail available in the guides themselves. They really are a great resource for you. Second, use the guides how they best benefit you. That may be flipping to your section or reading it cover to cover. Either way, it doesn't matter. Just use it how it works best for now. Third, find a takeaway in each guide that you can implement now and do it. There's something there for everyone, I guarantee. You can find something to implement. Fourth, use these guides to better understand how you should be planning for the future. Like I talked about, thinking what we build now, how we could reuse that in the future. It might be when you're buying your equipment fleet, you're purchasing new equipment, what does that mean for 10 years from now? Also, be on the lookout for new guides coming in the next few months. This is an ongoing process. It's going to take time, but it's super exciting. Up and coming are the water and climate resiliency guides. They're in really good shape, should be out relatively soon. Also, join the task group if you have interest. Again, just contact me. But I also want to say each guide is written by a different group of wonderful people who write these in their free time, which is really incredible. So I want to thank all of my colleagues on the task group, particularly my co-chair, Luke Deemer from the EFFC. Their hard work is for you, and it's truly appreciated. So with that, I'll hand it back over to Gerald.
Thanks, Kimberly. And I want to also use this opportunity to thank you for all your work that you're doing, not only in the Sustainability Committee, but also as chairing the work group that is together with EFFC, the European Federation of Foundation Contractors, and DFI to put these guides together. A very useful tool, and we'll probably talk about it more during the Q&A session. We now transition to another joint effort between DFI and EFFC, something that has been going on also for a long time. This one even longer than the guides. Started more than about 10 years ago or so. And Chris Nelsen will talk about the carbon calculator. Chris, the floor is yours.
All right. Thank you so much, Gerald. And thank you, Kimberly, for that fantastic presentation. It's so great to see all that work being done. And I currently use the guides, and I can't emphasize enough how helpful they are, and I'm so excited for the next ones. So Kimberly alluded to the EFFC DFI carbon calculator as a great tool for a number of different steps that we can take in the carbon reduction and circular economy guides. And so we thought it would be a good opportunity now to show you all what this tool is, where you can find it, how do you actually use it, and then talk a little bit about some new developments that are coming up as well. We have a separate task group between EFFC and DFI working on the development and maintenance of this tool, completely separate from the sustainability development guides, and they're doing great work as well. So I'll just jump in. All right, so this carbon calculator tool, what is it exactly? This calculator is an Excel-based tool to estimate carbon emissions for geotechnical construction projects, as you might expect. And it's based on dozens of case studies across 16 different construction techniques. And it was put together originally back in the early 2010s and has been continued to be maintained and updated in the intervening years. It incorporates life cycle stages A1 to A3, A4, and A5. If you don't know exactly what that means, don't worry. You can look at the carbon reduction guide and some of the other resources that are available to look at that. Those are specific stages in the construction of a new project. And one of the graphics that I really like to illustrate what this carbon calculator really is and the power it brings is this graphic here, which shows all the different construction techniques that are included in the tool and the different carbon emissions that they have broken out by relative percentages from waste, assets, people's transportation, mob and demob, freight, energy, and lastly, materials. And this graphic is so informative in that you can see the different percentages for different types of work and where those relative percentages may be, where your hot button issues are. And just at a quick glance, you can say, oh, if I'm doing dewatering, I really might want to look at my grid usage because energy usage there is about 50% of my total emissions. But if I'm looking at sheet pile walls, I really want to look at substituting or optimizing my materials, because the sheet pile material itself makes up almost 95% of those emissions typically. Now, as always, your mileage may vary with a graphic like this. These case studies are again about 10 years old, and we're continuing to seek resources to update these values. And you may find different experiences when you start to work on your projects. All right, so where can you actually find this tool? It's really easy. We made it really easy. You can just go to geotechnicalcarboncalculator.com, and that will pull up a website. It'll actually redirect you to the EFFC website, where you have two links shown here below. The first one is to download the EFFC DFI Carbon Calculator, and the second one is to download the methodology and user guide. I highly recommend downloading both, and I'll note this here. This should really be in bold, red, italics. That this link will give you the latest version of the calculator, which was updated actually just about a year ago. And it's really important that you continue to use the most updated version, because as I said, these carbon emission factors, the grid factors, as Kimberly alluded to, they're constantly changing, and we're updating that as we go. So make sure that you're downloading the new tool and using that tool so you have the most accurate estimates that you can. All right. So now that you've downloaded the tool, what does it look like? How do you actually use it? The next couple slides here are screenshots from the Excel-based tool. And I'll just kind of walk you through a very simplified hypothetical case study with not a lot of design behind it, but just to illustrate the functionality of the tool. And one thing that I'll mention before we dive in, that this is a macro-enabled workbook. And so if your firm or company or IT department has restrictions on using macros, you might need to talk to them about it to enable them for this particular spreadsheet. But it really does allow the tool to act in a dynamic way. So with that quick statement out of the way, this is what you're going to see on the first page when you open up that Excel sheet for the first time. You're going to have 3 tabs. Let me turn on my laser pointer. So down low, we have a README tab, which gives some basic information, a Home tab, and then a disclaimer. So we're going to start on the README tab. And the couple things you can change here are the language. There are many, in particular European languages included in this tool. There are also different emission factor databases that can be used. We recommend, unless you know specifically for a particular reason why you might want to use EPA or an EU-based emission factor database, we recommend using the EFFC DFI one, which is really tailored to geotechnical construction. And lastly, you can change the unit system here. On the sheet, you can also upload your company's logo. So in all the reports and different graphics that this tool will produce, your company graphic can be shown on there. All right, so moving to the Home tab, this is where you're going to start your sub-projects, your projects, and then you can see comparisons and results. So a little bit of the nomenclature here. A sub-project is maybe a subset of an overall project. Maybe you have a geotechnical project that has a sheet pile wall and then a soil nail wall on one side, and then you're also doing some deep mix and ground improvement in the site underneath your building. So if you have those different types of projects, within this calculator, you can create a sub-project for each of those, and then dial in your carbon emissions for those sub-projects, and then combine them into a single project so you get a final result for your overall project there. We can also then compare projects or sub-projects in the results and comparison tabs, which I'll walk through. For this example, I've included 2 sub-project examples. And so what I did is just enter a name in this tab. This tab here is actually a drop-down to select any of the geotechnical construction techniques included, or you can copy from an existing tab if you just want to do an iteration or see how a design may change. All right, so I started this first project. As you can see, I added a sub-project name. This is a jet grouting demonstration, and input some of the boilerplate information, date, name, working days, and workforce and project value are also included here. So you can then calculate your carbon emissions by value And also it will calculate your cruise transportation emissions as well. So looking at this, I want to highlight a couple things that the sheet does automatically for you. First, it'll populate kind of a standard cement or concrete slurry mix. And I've tailored this to use a standard cement type, but I've taken out the aggregate and sand that would be used here just to demonstrate a typical jet grout mix, maybe with some bentonite added as well. Again, these are very rough numbers, not meant to mimic a true jet grouting design. And then once I put in my quantity here, 1,000 cubic yards of jet grout mix that is made on site, all of a sudden this red box pops up and it says my energy emissions are relatively low. And this is a really nice function of the calculator based on those case studies that were used to develop those relative percentages of emission factors. This calculator knows that for about 1,000 cubic yards of jet grout mix, my energy emissions that are calculated lower in the sheet are lower than expected. So this gives me an opportunity to go down to those energy emissions here and increase the volume of fuel, in this case diesel by gallon, that I had, and all of a sudden in the top right there, that error message goes away, and you can see my energy emissions have gone up slightly. The other nice thing that I can highlight here is you see in this section here for MOB and DMOB, and it's similar for other secondary sources, that a simplified ratio is toggled in this case by default. And that's because based on the case studies, the only primary emission sources for jet grouting are the materials and energy. And those are individual sources that make up more than 5% of the total project's energy usage or carbon emissions, my apologies. And so for all other aspects, such as MOB or DMOB or people's transportation, that a designer or a contractor even early on in the process may not fully have calculated yet, there are simplified ratios so that you don't miss accounting for those even in early stages of design. So my next demonstration sub-project, just for comparison, I'll do a deep mixing one. So again, I entered same kind of boilerplate information, sub-project name. Just for comparison's sake, I use same working days and workforce equivalent. And now we see a similar result here when I'm using a similar mix, similar volume. But in order to get that error message to go away for the expected energy usage, you'll notice the energy emissions are actually quite a bit higher. In this case, 25 tons of CO2 equivalent, whereas on the jet grouting example, they were only about 6 tons of CO2 equivalent. Now, this is because based on those case studies, we found that in general, per unit volume of material used, deep mixing will use more fuel or energy usage in general than jet grouting. That may not still be the case. It may not be the case for your specific project, but it really helps kind of early on in the design and project development phase, kind of tailoring your expectations. So next, after we have those projects set up, we'll come into the results tab that will populate after you start your first sub-project. And then once you're on the results tab, there'll be a drop-down box here where you can select any one of your sub-projects or sub-projects or projects. And then this result sheet will automatically populate with nice pie charts and different calculated values for your emissions, broken down by value and broken down by the different types. After we're done looking at the results spreadsheet, we can then compare different projects. And this is really useful if you're looking at two competing geotechnical construction techniques, such as jet grouting or deep mixing, or if you're looking at design iteration, say you have an initial design that was provided by an engineer and you're doing a value engineered approach and trying to optimize board pile size or sheet pile sizing. So looking at these, the comparison tab has a lot of really nice graphics. First, a table of the emissions by category, again, going from materials and energy all the way down through assets and waste. And then as we scroll down through there, there are different plots that are automatically generated. The absolute project emissions in tons of CO2 equivalents. those relative percentages up to 100% of each individual sub-project, project emissions per project value. This is a nice one if you're trying to show the value of carbon reductions or how they compare. And then lastly, I really like this one. This is showing some uncertainty bars for the total carbon emissions for each project. And this breaks it down by the primary and secondary sources as defined by this calculator. So one last thing, after you're done with your comparisons, say you have a novel material you want to use for a project, or you would just want to dig deeper into the data and see where these values came from. The tool is built to be very transparent, so you will also have the option to look at this emission factor tab, which tabulates all of the emission factors used for any material, any regional electricity grid, people's transportation, and then there's also tables in here for those relative percentages of different emission sources. Those emission factors are all transparently provided, and you can also then see what database those are sourced from. And then if you really want to take that next step and go to that database, you can do that. There's also an area in the emission factor tab where you can if you have an EPD or an environmental product declaration for a product that isn't included in this database, you can go source that, and then there's an area to enter that as well, and then it'll appear in the drop downs for material usage on your different projects. All right, I think Kimberly and some others may have already added some links in the chat for some resources on how to use the carbon calculator. There are two more here that are linked. Recently, the Geo Institute had a summer school session on sustainability and geotechnical engineering where we presented case studies on and the usage of this tool. And then also we had a previous webinar back in September of 2023 as well. And the last point I will hit on here is we have a really great tool in this carbon calculator, but we're not done yet. We're going to keep on developing this and make sure that we have a tool that's good for the modern day, especially as we have new requirements coming out from different municipalities, different states, different countries. We really want our members of EFFC and DFI to be able to be on the cutting edge of these carbon calculations. So in particular, what we're working on right now is we're going to update the tool to go from this Excel-based format, which has its own issues with macros and downloading the form again and again and again, sharing, and moving to a web-based application where a lot of other existing tools are. Some of the benefits that we'll realize from this is we'll be able to connect to continuously updated EPD databases that are currently being housed on cloud servers, and we'll be able to link to those and make sure that all of the EPDs that you could ever possibly need are linked to the calculator. It will also allow users to save and share projects online within their companies or externally as well. In a bit of more internal perspective, it'll increase the ease of submitting and receiving case studies from EFFC and DFI's perspective so that we can continue to maintain our understanding of kind of the state of the art in geotechnical construction and the associated carbon emissions. We'll also maintain the ability to export the data and the functionality to an Excel-based file format, just so that people who are familiar with Excel or want to be able to tailor the results or create their own graphics have the ability to do so. And lastly, as I alluded to at the beginning, this will make sure that when you do log into this online tool, you're going to be using the most updated version. You're not going to have to worry about going to download the most updated version. You can just log in and you can rest assured that you're using the most updated one. So a little bit of the recent timeline and looking forward. In April 2024, the task group issued a request for information to different sustainability consultants and web developers to gain a little bit more understanding of what this process is going to look like. The development of this tool is going to be slightly different than developing the Excel-based version, although not greatly different. And then this month, we'll be issuing a request for proposals based on the information we received there. And then after we receive proposals, we'll be talking through this process with the EFFC and DFI boards in October, and then through to the end of the year. And hopefully by next year, we'll see this new development start off. And that is all I have. So I will hand it back to Gerald, and I'll just say thank you all for being here. Thank you for your interest and your continued work in this area.
Well, now let me just add to that, Chris, thank you for this presentation, but also for your involvement with the Sustainability Committee, and especially your role as co-chair of the DFI EFFC work group dealing with the carbon calculator. Appreciate all the work that you're doing there, and this was give people a good idea what the carbon calculator can do and how it can be used, and hopefully people will start to use it more and more widely. And one final suggestion to the attendees is, if you do use the carbon calculator or you have questions about it, don't hesitate to contact us. The reason that you see today some examples about grouting and some ground improvement things was feedback that I got, and Chris immediately picked up on that and included already in this presentation. Greatly appreciated. Third tool that we're going to present after the guides and the calculator is a flowchart, and that is a flowchart not necessarily worked together already with EFFC. It's a product that Will Haasz has been spearheading as part of the DFI Sustainability Committee, and he'll be talking more about this environmental sustainability flowchart. So Will, floor is all yours.
Thank you, Gerald, and thank you, Chris and Kimberly, for that detailed overview of the guide and the carbon calculator. I'm going to try and incorporate, those into my presentation here, but I think it'll become evident just following the flowchart how they can be incorporated into really anybody's routine when it comes to working in our industry. Gerald kind of mentioned it, but just a small disclaimer. I plagiarized this tree with a drilling rig graphic from another slide, and EFFC actually hasn't been a part of this flowchart that we've created. They're probably not aware of it, but I just wanted to make that known that if EFFC is not happy with the flowchart, then we can remove it from the presentation later on. But just wanted to point that out there. So really, our flowchart, right? This kind of sums it up, is that in order for us to achieve the highest possible reduction in carbon, I think it's important for all of us to work together to reduce the environmental impact of our industry, right? And finding common ground was at the bottom of this slide, just in the presentation across the board. And I think that really echoes, what this kind of flowchart entails, is that we have to find common ground across our industry to come together to really focus on minimizing our carbon impact and our environmental impact in general. So a little bit of a background here, like why did we make this flowchart? Why did we come up with it? So when I first joined the DFI Sustainability Committee, after a few meetings, it became evident to me that there was a lot of different people from a lot of different disciplines in the committee, and each time we met, it was kind of difficult for me, and I'm sure for others, to kind of grasp how we can make a difference meeting together when some of us are coming from a consultant background, a contractor's background, specialty contractors background. I think we have equipment manufacturers like Bauer is in there. We have energy pile experts. We have academics, professors, and graduates that are doing research, and even excavation and supportive excavation specialists. So it became pretty clear to me early on that it would be helpful to make a flow chart so we can kind of visualize how our different, let's say, parts in a project work together, or lack thereof work together, and how we can kind of visualize that to see where we can kind of target improvement in our industry. So I began kind of just creating a flow chart and got feedback, worked with people in the committee to improve it, met with the technical committee of DFI and made some changes. And now we have this flow chart. And, the idea was maybe this could be useful for anyone in our industry that's trying to make a difference when it comes to, reducing carbon impact and improving our environmental sustainability. So that's pretty much the background. That's here we are. That's where we're at now. And basically, I think it's on us in our industry to kind of think ways that we can think outside of the box and work around traditional constraints that are associated with a standard project timeline and, the different players associated with the development of a project. And in order, to do that, we just wanted to kind of make a very simple flow chart. So initially, this is the actual flow chart. It's still in draft form. So the idea is that we're going to publish this probably in DFI magazine and accompany it with an article. But after meeting with the tech committee, it's a little overwhelming to look at, and certainly for a PowerPoint and talking to all of you, we don't want to be zooming into all of these. So instead of kind of looking at it, on this billboard that it should be on, we've chosen to kind of break it out into individual components. So before we get into the flow chart and everything, the actual process and how things are related, I think it's important for us to kind of take a step back and look at the traditional project timeline, which I've very much simplified here, but you can kind of see, we go from the owners or developers coming up with a project concept. And from there, it goes to consultants who then, work with each other to come up with schematics, design development, and ultimately construction documents. And then it goes to general contractors. And then lastly, most of the time, the deep foundations contractors get involved. And to kind of symbolize the lines of communication here, you can see most of the time, the green arrows at the top, right? There's pretty much mostly strong communication between owners and developers and consultants and general contractors. Maybe sometimes general contractors aren't involved because they're chosen, later on in the timeline. But for the most part, the synergy between those players is pretty good. But when we get down to, consultants and then general contractors, and then furthermore, deep foundations contractor, that's where we start to see the yellow and the red lines kind of indicate that there's not as much, communication and really ability to make changes at that point between, let's say, general contractors and consultants. And then certainly, at least from my point of view, working for Menard, a specialty subcontractor for ground improvement, a lot of the times, by the time we get involved, it's very difficult for us to have an impact upstream, let's say, on the consultant side, because a lot of things have already been kind of paid for, designed, printed to paper, planned, and costs, have all accrued. So it's very difficult for us to really make any changes upstream. And really, that to me is my experience with traditional project timeline. I know that can vary, and there's certainly examples of synergy between any one of these players that works out. But for the most part, I think that's really what we're looking at in terms of how a project comes to fruition. In this, you can imagine there's a lack of effective feedback loops that really where insights from the construction phase, like the action phase, we're calling it in the flow chart, where the deep foundations contractor, the general contractor, right, might be able to do something to reduce our impact that without the consultants or the owners and developers knowing that, then chances are that it might never get done, because by the time it reaches that far downstream, the wheels are already set in motion, so to speak, right? So really the absence of environmental sustainability considerations during those upfront planning raises the chance of expensive modifications later if any changes are possible. So most of the time, this results in missed opportunities that otherwise could have reduced the project's environmental impact. So in order to move forward, which I'm going to talk about on the next slide, which is reimagining the project timeline, really, like, if you think about it, the communication of a traditional project hierarchy is oftentimes obstructed or non-existent due to like how rigid things are in a traditional project timeline, right? You have this stepped process that you're taking, and by the time a general contractor, any subcontractor is involved, kind of think the project is already set in motion in a way that costs have been made and things have been planned, where if somebody does have an idea or a methodology to reduce carbon, can't really implement it because it would involve a lot of changes to other people's or other businesses or subcontractors' work, right? So that's really at the core of a lot of what this flowchart kind of aims to, have people focus on. So kind of rethinking the project timeline, right? This is kind of what we imagine things should look like. And you can see here, right? The idea is that, an owner developer has a project concept, and instead of it just going, straight to consultants, which it's still the brunt of the planning and the design work for most things will have to be done at a consultant level. But if we prioritize collaboration between general contractors, consultants, and deep foundations contractors, we will see a likely increase in our reduction to our environmental impact, right? And when I say consultants, I'm speaking of many different consultants, right? We have geotech, structurals, architectural, plumbing, mechanical, the list goes on. So really, there's a lot to be said about how we could collaborate better. And I think that's something that as a whole, the industry needs to focus on and work on, whether it's through, marketing and lunch and learns, education, training, but really it's just developing synergy. So if we focus on the development of feedback loops and partnerships, especially when the primary hierarchy of a project has been established, you can imagine that that's going to lead you in the direction of reducing the carbon impact to its highest capacity. If we kind of find common ground and nurture the idea that getting feedback and a good understanding of contractor and industry capabilities on the front end, that can lead to a significant reduction in environmental impact. And a lot of the times what we're seeing, it can even lead to a reduction of cost for the project, which is a selling point for many, owners and developers, if we can highlight that. And when we really focus on communication and practice working together in our industry to get together, we can make a difference for the environment. So get into the flow chart, kind of broken out into different segments here. So really now we're going to talk about at each level what could be done by, let's say here, the owners and developers. Really they're tasked with imagining an environmentally sustainable project, right? And you ask yourself how to do that. Kimberly mentioned it earlier, but always promoting performance-based specification instead of like a rigid criteria, which in my industry we see a lot, and it's it's like we have to follow the rigid criteria. But if we were given some more performance-based specifications, then we could play with and ultimately use the carbon calculator and come up with something that was going to meet the demand, but also reduce carbon. Really, there's also marketing opportunities. So the idea that an owner developer could say that, we built this carbon neutral building, it's got energy piles, it's, solar panels, the foundations are half reused and the other half are very low carbon concrete, all sorts of little things like that that maybe an owner or developer might be intrigued to implement something on the construction side that they could brag about later, right? And then really the most important part is the owner and developer and even their consultants seeking incentives for sustainable foundations, right? So I put here to just consult the circular economy and carbon reduction guides and the guides that, Kimberly mentioned. Obviously, a lot of great information in there, and it's something that really, if you're any one of the players in the project, then it's going to be a good idea to consult those moving forward. State and federal government incentives. Is there any client incentives? Meaning, if they're building an Amazon warehouse, does Amazon have any incentives to reduce carbon? I don't know, but it's always worthwhile to ask. Could you use recycled local materials? Could you reuse existing foundations? How could we perhaps, do something with the foundations that can secure them a LEED certification or help get them in the right direction towards achieving LEED certification or some other certifications? And then the last thing I put here is energy piles. So the one thing that we realized early on in the Sustainability Committee, having several people that were involved in energy piles, is, let's say at the construction level, we can say that we can install them, but we can't really sell that outside of just saying we can install them. If we want to start seeing energy piles implemented, really it has to be envisioned at the owner developer level and the consultant level, right, in the planning side. Because when you're incorporating energy piles, it has a huge cascading effect on what needs to be done for structural, the foundations, architectural, mechanical, plumbing, all of that stuff, right? I'm not an energy pile expert, but from what I've seen, it can be quite expensive and exhaustive to get to the time where you have to install piles and then say that you're going to use energy piles, right? All the HVAC, the design that goes into that really needs to be envisioned on the front end. So that's owners and developers. And then we get to consultants. And really, this is kind of just a guide to follow as a consultant, right? Like, has the owner developer specified any environmental sustainability recommendations or requirements? If the answer is yes, then you're designing an environmentally sustainable project, and you just kind of carry that through to the end, right? Focusing on partnerships, collaboration, and getting feedback from the construction side to make sure that whatever technique or design you're implementing is achievable, and maybe there's an opportunity to achieve even more if you have the feedback from the construction phases. If the answer is no, then really it's just a question. And a lot of the stuff that I see in our industry is if you just ask the question, even in our own business, what can be done, it might just intrigue the owner, developer, the client to do something, right? And just that little tipping point can lead you in a direction of reducing carbon that maybe otherwise would have never happened. Really, for our industry, I think there's the strongest opportunity to reduce carbon impact at the geotechnical and the structural level, because oftentimes you can imagine if there's a disconnect between the structural foundations and, let's say, ground improvement or the piling contractor on capabilities or what they could do to lower carbon, then it's very difficult to make changes after that's already been kind of, the plans have been set in place, right? You can imagine a structural engineer designing a whole building, footings and everything, and then to get to the next step, to have the contractor say, well, if you did this, we could do that. That's the sort of thing that kind of stops us in our tracks and leads us to kind of continue along the traditional path of just doing what was designed in the first place. So at a geotechnical level, I'm sure we could point to stuff for the structural level, but at a geotechnical level, obviously, I think it's something that we're all aware of and have certainly dealt with a lack thereof adequate geotechnical investigation and testing. So whenever you're in the beginning stages, if you're going to have foundations, it's in everybody's best interest to have, you know, the right data and as much data as you need to plan and design appropriately. Again, considering performance specifications instead of rigid criteria, and then also consulting the EFFC and DFI guides that we mentioned. And then over here, just the catch-all, right? Like seeking partnerships and guidance from each other in the consultant world to better understand, you know, what might be needed or could be done between site civil, architectural, mechanical, structural, geotechnical, and then obviously energy piles is here as well. Same thing. If you're going to do energy piles, it's very important that that's kind of hashed out in this phase as opposed to later on. Then we get to general contractors, right? And it's the same. It's the same sort of you know, logic, right? Has the owner, developer, or their consultant specified any environmental sustainability recommendations or requirements? And if the answer is yes, then you proceed as normal, right? And then you ask yourself, well, have you proposed any value engineering that would have a positive impact on environmental sustainability, right? And if the answer is yes, then you have the opportunity there to provide alternate proposals for improved environmental sustainability. If the owner developer, just like before, didn't specify anything, the answer is no, just go back, see if there's an opportunity or an interest at the owner, developer, and consultant level, and then you just iterate back into the loop. And if the answer is no, then you just carry on. If it's yes, then you're in a better spot and we're on track to reduce our carbon impact. As the contractor, if you haven't proposed any value engineering that would have a positive impact on environmental sustainability, and the answer is no, then that's where, as a general contractor, it's kind of the same sort of thing in terms of marketing and seeking partnerships in order to sell, plan, and construct more environmentally sustainable projects, right? And to do that, the idea is to, you know, seek more partnerships with consultants, deep foundations contractors, and of course the owners and developers to work towards that goal. So this is where, you know, obviously I said I'm from Menard, so this is the brunt of my experience and knowledge. So at the deep foundations contractor level, and really in any, you know, subcontractor or contractor level, this is kind of like how I imagine it's going for everybody, right? Like you're in a position where you're bidding a project and you in your pre-bid, you can do some sustainability assessments and, you know, understand that you could propose value engineering to reduce the impact. And if that's the case, you're kind of, you know, moving into an alternate proposal to present to the client that they have the option to choose or not to choose, whether it costs more or less. Sometimes maybe it could cost more, but in our experience, most of the time it costs less. If the answer is no, then you're bidding it as specified. But the idea is like you should seek marketing opportunities to build awareness of your capabilities in terms of environmental sustainability, right? And in our scenario, right, we want to market to owners, developers, consultants, general contractors that we're capable of reducing impact by using low carbon cement or an iterative design process. As you see down here below, where post bid, after you've kind of chosen a technique or a deep foundations type, this is really where most of the contractors live, right? And the carbon calculator falls in line, is you're going to now take your requirements and then iteratively kind of run through your design to ultimately come up with a solution that is least impactful or that has the highest carbon reduction possible. And that's kind of where, you know, in Chris talking about the carbon calculator, that's like what I think most people are doing. But you can see that had things happen further upstream, by the time it got to here, the impact could be a lot more significant than just what, let's say, the specialty or deep foundations contractor could do there, right? All right, so basically kind of to sum that up is like we need to foster synergy between the planning and construction phases regarding environmental impacts. And I think that's extremely important, and really, like I said, like if you're not in the know of the capabilities of one side versus the other on the action and planning side, then you're going to just continue doing what you're comfortable with. And that's how kind of things stay the same without legislation or regulatory, government laws and stuff that carbon tax, carbon credits, all that. Without that being implemented in the United States, we're kind of left to our own moral compass in terms of doing something sustainable. So best way to do it is to foster synergy between the construction and planning phases. So in order to do that, really what we've been talking about this whole time is like to build a better system of being informed about one another's abilities to minimize environmental impact, right? So if you're a contractor, it's, you know, time to start thinking about lunch and learns, you know, educational webinars such as this, or not this, but similar to it, and just start to get the message out what you're capable of. So then, you know, owners and developers are aware and they can start asking for, you know, those capabilities or those products that you're selling. Consultants can begin to work with you to better understand how you're going to do something and how they can specify it, and in some cases design it. And really just taking small, thoughtful steps during the initial stages of project planning can lead to a more substantial impact than would have otherwise been possible. So I like to say this is like a snowball effect, but it's kind of I don't like to use the snowball effect because, you know, at the end, you don't want a bigger snowball to be associated with more carbon. But if you take small steps in the beginning and get a bigger snowball, and let's say that's your carbon reduction plan, at the end of the hill or the stream, as I've called it several times, your snowball will be much bigger. And that's basically the analogy, right? Take small steps in the beginning and then you'll get a higher net result at the end. And then the other thing here is just regardless of anybody, and this has truly been my experience in our business unit, is regardless of your position within a project management structure, you can make a meaningful contribution by simply suggesting that further research could improve the final impact of a project has on the environment. So, you know, anybody that's involved on the planning side or the construction side, I find that it's best to just bring these things up, ask the question, and then most of the time, if it leads to a carbon reduction, hopefully it leads to a reduced cost. And it's really kind of kicking people into gear to rethink that, you know, maybe the standard process of doing a design could be improved if they took another stab at it in terms of carbon impact, right? And that comes back to using the carbon calculator. And oftentimes it's the harder part to do because you're asking, let's say, designers to, you know, iteratively do it, run through a design to come out with a optimal solution with respect to carbon impact. So that can be difficult, but if you begin to think about how you can set up your design software or spreadsheets or methodology to accommodate that iterative process, that can help tremendously. And then really lastly is kind of bringing it all together is like working as a team, right? Like I said earlier, like the traditional project timeline and the traditional project hierarchy is very rigid, and it's difficult for anyone downstream to make a change that's going to have the highest net positive, reduction in carbon impact or environmental impact. So, it's kind of analogous to any team sport, football, basketball, hockey, whatever it is. Like if you practice on your own, or you coach one individual and you don't have the team practice together, you're obviously not going to play as well as compared to if you had practice together. And it's very similar to this, where if we just begin to practice getting feedback, developing partnerships, better understanding each other's capabilities, ultimately it'll lead us in a direction where we're going to start to see a lot bigger change and maximizing our carbon footprint reduction. And I believe that is it.
Thanks, Will. Thanks for a great presentation. And also thank you for all your efforts that you put into this flow chart. It was your suggestion to do this, and really truly appreciate all the efforts you put into to make it reality. The last 15 minutes of this this webinar, we'll use the Q&A, and maybe DFI can switch off that slide for the time being, so that people don't have to look at that big Q&A, instead of can look at the speakers. And the first question that came up, and in a way Will must have anticipated it, because he really kind of answered it as part of his conclusions, but that is, I'm a young engineer and I'm very excited by the material presented here. What can you suggest I can do to make sure that these tools will be used in my company? And since Will already answered quite a bit of that, let's start with Kimberly, then go to Chris, and then back to Will to see whether he wants to add anything to that. So Kimberly, any suggestions for this young engineer?
I say, who else is going to do it if not you? We need the young engineers. That's who helps me so much. You have the energy, excitement, and the willpower to do this. Using these guides is so helpful, because your company likely, is paying for you to be a member of the DFI, to say, here are these resources you've contributed to monetarily. Let's actually use them and put them into action. There's so many just great ideas in the guides to give you, specific things we can do. And, showing those metrics on how we can measure it and do better, I think is really great, particularly using the carbon calculator. I mean, this real hard numbers, right, that you can take to your managers to say, look what we're doing. And it wasn't that hard. I think you'll find, we were talking about the carbon calculator, the first time you use it might take a while, but the second time won't, most likely. So just getting started, like, you're, as a young engineer, probably going to be the one to actually do it. So we need you. Get started.
Good. Chris, anything you wanted to add to that?
Yeah, it's a tough position to be in, especially if you don't necessarily have the at least outright support from your management saying, hey, we need to do this, and you're trying to convince them to do it. If you are able to do it once, and just show the ability and how you can do it is one thing, but then also use some of the resources that Kimberly provided, kind of the upcoming legislation where companies are going to have to report, and just kind of make it known that this is the trend of the industry in general, and show that you can be the person that does that, or other folks in your industry, in your company, can do it as well.
Okay. Will, anything more that you want to say to this and what you already did?
No, I think that about sums it up. I mean, it's just about, raising the question, right? And if you're a young engineer, designer, whatever you may be, it's just about, like, when you're in those scenarios where you're talking to your manager, maybe take that extra step, and in your design spreadsheets, or, in the output from your design platforms, just add a little simple chart or table that summarizes the carbon impact, and say, hey, look, this is what our carbon impact is. I took the liberty of running it again by changing a few things, and looks like if we reduce the cement by about 5 pounds per yard, we could save, 100,000 kilograms of CO2 or something like that. Little initiatives like that.
Okay. Let me, as chair of the Sustainability Committee, add one more option. to this young engineer, suggest to your management to join the Sustainability Committee. Because if you're then part of the Sustainability Committee, you hear more about these tools, and then you can come back to your company and say, hey, this is what we're talking about in the committee, something that we should be doing as within our own organization as well. And I would welcome you as part of that committee any time. The more people that we have, the better. And there's a lot of very interesting work that's being done, because don't forget, the work that's being presented here was not just the work done by the 3 individuals that presented here. As Kimberly already mentioned it, it's a team effort. Quite a few people have been involved in this whole thing, and we can always use more people. The second question, yeah, but still time for that. Second question I have is based on something that Will presented in his presentation, where he said that contractors can really use sustainability as a marketing opportunity. Since all 3 of you are working for contractors, how is that being done in your own organization? Is that something that you guys are doing on a regular basis, or is it something that you think can be done more? And let's, again, since Will already brought it up, and he can tell a little bit more what Menard is going to do about that. But let's start this time with Chris.
I'd be happy to start, and I'll just put the plug in that I work for a consultant, actually, so it might be a slightly different spin on the answer. I previously worked for a contractor, so I have a bit of that experience as well. Yep. But on the consulting side, some of the stuff we're doing, I think at this point, we are doing a lot of work to catch up with the cutting edge, and very actively. We are internally redoing our sustainability policy, which was authored, I think, about 3 years ago. So we're updating it, and I'm actually using the sustainability guides as a really key reference for some of that work. I would say beyond that, once we have that, we can show that we are experts in that field, and then also use the upcoming legislation to convince our clients that that's something that they want to pursue. On my current project, I'll make a plug here for Envision, which is a sustainability rating system specifically for infrastructure. So it's an area where my company works a lot, and I know a lot of D Foundation projects are more for buildings, where they may pursue something like LEED. But Envision is a really good structure for that, and we've had success in showing clients that this is a good way to kind of set up your projects, think about all these things holistically. It really ties in well to the flowchart and some of the other guides. So that'd be my other plug.
Okay, Kimberly.
I think that you're going to have clients or maybe sectors where this is a valuable marketing tool, and some of them it won't be. Doesn't mean you shouldn't do it. Certainly, if you're just getting started, a good place to start is with clients that care, or projects you know that it matters. Like, why not start there? You know, you're going to get another benefit from it, you know, which in this sense is marketing. I'll just say, you know, use the recommendations from the sustainability guides about metrics and KPIs. Like, if you're going to go out and say something is more environmentally sustainable, you need to have the data to back it up. So just be a little careful about that. Make sure you've done the work to bring that forward to your clients, especially those that are in the know about what is sustainable or lower carbon and what's not. But in general, I think in a sense of marketing, it's a lot of our clients don't know what we could even do and don't know what we can offer. So the carbon calculator and the guides provide these resources that say, this is the impact we can have. With case studies in the new carbon reduction guides, you can see like, wow, this is a lot of carbon, and you can use that to talk to your clients. Say, this seems significant to you. Is this something you're interested in? We can do this for you. So a lot of times it's just bringing it up, letting people know what's possible and what we could do that our industry actually can have a really big impact. And I think in general, we're often overlooked. So just getting it out there and talking about it, bringing it up, I think is kind of a good first step for marketing, in my opinion.
No. Well, anything else that you want to add to that?
Yeah, I mean, I think our company does a fairly good job of this in terms of marketing our capabilities and what we can provide to the client, but there's definitely room for us to develop our um, our our case studies and our means of, you know, explaining to our clients like how we can provide a reduction in carbon. I think there's always room for that, but really, as contractors, like we can do the iterative process and optimize our carbon impact. But it really comes down to like whoever is planning on the front end, getting in front of them to make sure that they understand what's possible on our end before they go designing something else that is going to be a lot more impactful. So all that to say that I think we as a company at Menard could do better at marketing this. And I mean, one of our marketing things right now is less is more. You've probably seen that before. So that kind of says it all in one phrase. But yeah, that's really all I have. I guess I was on a meeting this morning about our environmental reporting and our parent company, Vinci. You know, they're based in France. So even though we're in the US, like Kimberly had mentioned, like we have to report scope 1s, 2, 3, and we have to have a reduction in all of those by 2030, you know, of a significant amount. So even though the legislation and the regulations aren't here yet and they're coming, we still have to do that. And maybe that can be a marketing opportunity, you know, just kind of a standardized thing that you bring up to any client that you're working with is like, are you owned by a European agency that has to follow strict carbon laws or regulations? And if you are, then, well, we can provide you with we're going to try our best to optimize, but if you have to do that, you could report, you know, a savings that would otherwise not be realized unless you had that conversation. So for the most part, for me, it all comes back to conversations with clients and the owners and developers to make sure they're aware of what we're capable of.
Okay. Unfortunately, our time is up, so the remaining questions will have to wait until another time. I want to thank all three of you for making these presentations, for being here, and obviously I also want to thank all the attendees that they were here did this webinar. When it comes to the admin part of the whole thing, if you pay to get PDHs for this, please wait, give the staff a little bit of time to get those PDHs before in your hands. And if you have any suggestions for webinars or any suggestions about activities in the DFI, you see there the locations where you can register for the webinars or can give feedback on this whole thing. Finally, I want to make one more plug for another DFI event, which is the upcoming annual conference that you see there. It will be just outside Denver in Aurora, Colorado in October. On October the 7th, our committee will meet, the Sustainability Committee will meet there, talk about more, not only the 3 items that you heard today, but all the other activities that the committee is involved with, so that you can get a good flavor of what the committee is doing. And please feel free to join it. You don't have to be a member of that committee or any of the committees that are the DFI has. You can just walk in, listen to what they're doing. And in our case, we always make it a very special effort to give people an opportunity to make suggestions, what they would like the committee to do, so that hopefully we can then provide the tools that you can implement sustainability more effectively. And with that, we've come to the end of this webinar. Once again, thanks to the speakers. Hopefully you enjoyed being here as an attendee, and I look forward to seeing you in the future when we do something else in the area of sustainability. Thank you very much.
Thanks, everybody. Bye-bye.
Yeah.